Okay, let's do problem 2, add two numbers. Here we're given two singly linked lists, and then we have to add those two lists. So they actually represent a reverse order of the numbers. So this 243 actually represents the number 342. So this question is designed so that we can easily solve the problem, because if you have 17 plus 18, we add the last digits, have carry, and then add those three numbers. So we are going to use the same principle. Suppose we have 7, 4, 3, and then 5, 6, 4. What we are going to do is we're going to have carry of 0 initially and add these values to carry. So carry becomes 12. And we're going to get the last digit of carry and create a node. And then the carry now becomes 1. So in the next iteration, these two numbers will be added to 1 and so on. The question is, how can we get this 2 and then how can we update our carry? It's fairly standard. We just do 12 modulus 10 is equal to 2, which is the value of the node, and 12 divided by 10 is equal to 1, which is the new carry for the next iteration. And we are going to have a while loop going through each of the node. But if you look at example 3, the nodes aren't necessarily of the same length. So if this is gone, so if you have only one node, we add only that value to the carry. So in our while loop, we do need L1 is not equal to null, or L2 is not equal to null. The reason we used or is if we use and, if one of them is null, this while loop breaks, which means after going through the second iteration, it will break, rather when we have to work out the last node for the first list. So this or allows both of them to be null, and then while loop breaks. So we do need two if statement, which is L1 is not equal to null, and if L2 is not equal to null. And then we do need int carry equals 0. We simply do carry plus equal L1.val, and then move L1 is equal to L1.next. Do the same thing, carry plus equals L2.val, and L2 is L2.next. And the most important thing is creating the logic for creating each node. So I'll give the wrong example first. So if we have, say, if we have list node of current equals null. If we do current is equal to new list node of carry modulus 10, and then carry is carry divided by 10. And then we have car.next is equal to null, and car is car.next. So what's wrong with this is we create a node of 2, and then it's pointing to null. Now this is current, and in the second iteration we set current equals new list node of, so we're essentially creating another list node of carry, so it will be like 1 here, and then we're essentially moving this pointer to this. So there is no connection between 2 and 1. So to solve this issue, we need to have a list node of dummy equals new list node of 0, for example, and this car should point to dummy. And then we can have car.next is equal to new list node of carry modulus 10, and then carry update carry, and car is equal to car.next. So by doing this, we created a dummy here, and then dummy's next is 2, and then current is current.next, so now this is current. And then in our next iteration, it will correctly create a link. And then when everything's finished, we can simply return dummy.next, which is the head. So not only it solves the issue, but when returning the head, which is what's often required, introducing dummy node helps us easily track the location of the head. And there's one more issue, which is this. If you have this, we still have carry of 1, but our condition is satisfied that we don't have any nodes when we have one carry. So that carry is ignored. So we need to update our condition that if carry is greater than 0. Okay, let's run the test. Okay, let's submit. Okay, that's it.